In question 8, we're going to be doing some crispy Euclidean geometry. Okay, so the center is at O and PUK is a tangent. That's quite important. I'm going to mark that off. And additionally, TS is parallel to PK. That's been indicated with these little arrows over here. That is a straight line. Cool, we do have eyes, so we can see that. And the angle TSU is 75 degrees. And firstly, we need to calculate with reasons the size of O1. So O1 is sitting over there, and the only thing I really know is that this is 75. So I kind of want to form a relationship with the information I know and the information I want. And we're going to do that with the following theorem. Angle at center is 2 times the angle at the circumference. So if I have an angle at the circumference, the one at the center is 2 times the size, provided they're subtended by the same quarter arc. So applied to this particular example, I'm going to highlight it to show you a bit better. So we start with that 75 degrees, we go to the 2 lines that it's touching, and then we follow it down to get to our chord TU. And then once we've recognized our chord, we follow that to the center. So we go up these 2 lines. And when we go up those 2 lines, it takes us to O1. So we officially know that O1 will be double the size of S. Now you can also trace the lines like this to kind of form an arrow shape. But that's a little bit unreliable because sometimes it can look like a bow tie, sometimes it can look like an arrow, sometimes it can look like a diamond. So you really want to get into the habit of that first one where you follow it down and then up again. And 2 times 75 is 150. Now let's see how we're going to communicate that and write that down. Okay, so you always want your statement to match your reason. So the angle at the center O1 equals 2 times the angle at the circumference, which is the 75. And 2 times 75 will give you 150 for O1 as we discussed earlier. And let's have a look where the 2 marks come from. You're just going to get 1 mark for your statement and 1 mark for your reason for this question. Next up, they ask us to get U5. And U5 is over here, and I can see U5 is nested between a tangent and a chord, my friend. And there's a theorem that ties in a tangent and a chord. It's called the tan-chord theorem. Let's go through it quickly. The tan-chord theorem states the angle between the tangent and the chord is equal to the angle that the chord subtends. So you follow the chord down to the circumference to get the relevant angle that will be equal. So applied to this question, I've got to follow my chord down to the circumference to get the angle that will be equal to U5. So if we follow that chord down, it takes us to the 75 degree angle. So I know that U5 will be 75 degrees after I've applied the tan-chord theorem. Let's have a look how we're going to write that down. So I can just jump in straight and say that U5 is 75 degrees for the tan-chord theorem. And you're going to get 1 mark a pop for each of those because it's only a 2 mark question. So as discussed, 1 mark for your statement over here and 1 mark for your reason of the tan-chord theorem. Next up, we've been asked to calculate T1. T1 is sitting over there and it's touching quite a special line over here. He's a sneaky weasel, boss. It's a radius, my bro. I can see another radius over here, hey? Which means that those 2 lines have equal lengths. OU and OT have the same length because we recognize that they're both a radius of the circle. And we're going to use the properties of an isosceles triangle to solve for T1. Okay, so firstly I need to state that I recognize that those 2 radii are the same. So I'm going to say TO equals OU radii. And we just state it like that. TO equals OU radii. Now we're going to use the properties of an isosceles triangle to figure out T1. So if these 2 sides are equal, it means that these 2 angles have to be equal. T1 needs to be equal to U4 for the following theorem. And that theorem states angles opposite equal sides. So if I have equal sides, the angles opposite them have to be equal. So that means that T1 has to be equal to U4. For this reason, angles op equals sides. And we just write that down like so. Okay, after we know that those two angles are equal, we're going to use the following property of a triangle to calculate them. So it's interior angles of triangle. I know that all three of the angles inside of a triangle add up to 180 degrees. So we're going to write it like this. We say that T1 equals, and then we do quite a big fraction, and we say 180 minus 150, and then we divide that by 2. Let me quickly explain the mechanics of that line. If I say 180 minus 150, it gives me the size of both of these angles added together. So this one plus this one is 30 degrees. But we know that they're the same size, so I can just divide that by 2 to get the size of T1. And that you can pop straight into your calculator. And after you pop that in and press equals, it just gives you 15 degrees. And that wraps up 8.1.3. Quickly having a look where the 3 marks come from. You only get awarded this mark if your statement and reason are correct. So if you have both of these in place, you earn this mark. And then you get 1 mark for this statement and reason, and 1 mark for your final answer. In 8.1.4, we've been asked to get the angle V. The angle V is down here. And V is in quite an abstract place in the circle. What I am noticing is V is an interior angle of a cyclic quad. So it's the cyclic quad TUVS. Let me highlight it so you can see it better. Yeah, it's much better. So our cyclic quad is over here. So I know that V plus the whole of T will give me 180. So if I can find a way to either get T2 or the whole of T, I can quite easily get V. And a good tip with Euclidean is you kind of have to work backwards from your answer to see what you need to do. Okay, so T2 is going to be quite difficult to get. So I'm going to rather get the whole of T in one shot. And I'm going to do that using the parallel lines. I can see that the whole of T is sitting in an armpit of a Z or an N, alternating angles. Let's quickly go through that theorem. So with alternating angles, if you're told that these lines are parallel, then you know that the angles in like the armpits are equal. So we're going to apply that over here. I'm going to draw the Z so you can see it a bit more clearly. So our Z is over here, highlighted in like this aquamarine greenish blue. And we can see these lines are parallel, so I can draw the Z between them. And if this is 75, it means this whole angle will be 75. Okay, now let's see how we write that down and communicate that. So our reason is going to be this, alt angles, but we've got to state which lines were parallel that made this possible. So for our particular case, line PK was parallel to line TS. And then we've also got to show the relationship between the two angles we saw that were equal. So it was angle U5 that was equal to the whole of T. And if I'm using the whole of T, I just put T with an apostrophe or a copy on top. And I could have also said like UTS, but it's quite good to get in the habit of just saying T if you're doing the whole of T. And both of them have a magnitude of 75 degrees. Now that we know the whole of T, we're going to come back to our cyclic quad. And the theorem for the cyclic quad that we're going to apply is the opposite angles of a cyclic quad add up to 180 degrees. So the whole of T plus V will equal 180 degrees for this reason. And we just write it like this. Angle T plus angle V equals 180. Now we know the whole of T is 75 degrees, so we're going to change this to 75. And then we take that 75 over to the other side and we minus it. And after we do that, it should give us 105. Double triple check yourself with your calculator. Don't make silly mental math errors. Okay, just to triple check, it does give me 105, so V has a size of 105 degrees. And lastly, we're just going to have a look where the marks come from. The correct statement and reason get you your first mark. And then over here, your reason gets you your second mark. And the correct value of V will get you the third mark. Alrighty, welcome to your challenge round. We need to calculate U3. U3 is sitting over here. I can see U3 is inside of this triangle over here. So if I had the other two angles, I could calculate it quite easily, but I don't have G2, so that's a problem, and I need to find another way around to get U3. So we're actually going to apply the tan chord theorem with U3. And the chord in this example is US. And let me walk you through how we're going to do that. So we need to identify the angle between the tangent and the chord, which is this big angle over here. It's U3 plus U4 plus U5. And then I follow my chord down to get the angle it's going to be equal to. And after I follow it down, it takes me to that 105 degrees I calculated earlier. And we know U4 and U5, so we can pop those in place there and then work out U3. So let's see how we're going to write that up. So I'm firstly going to state the letters before I put the numbers in. So I'll say U3 plus U4 plus U5 is the same size as V. And I knew that because I applied the tan chord theorem. And now U3 is going to stay behind because that's what we're calculating. U4 we calculated to be 15 earlier, so I change U4 to 15. U5 we calculated it earlier to be 75 degrees, so I'm going to change U5 to 75. And V, we have V to be 105 degrees using that cyclic quad earlier, so we'll change V to 105. After those changes have been made, the mission is to solve for U3. So 15 plus 75 is 90 degrees. I'm going to take that 90 degrees over to the other side so that I can get U3 on its own. And when I do that, it becomes a minus. And 105 minus 90, I believe it's 15 degrees. Just triple check yourself with the calculator always. Yes, 15 degrees. And your 2 marks only come from the statement and the reason in this question. Just bear in mind you don't have to show all this working out. I could have just jumped straight from there to the answer if you're comfortable enough. But I like showing my working out. It helps me and it makes me more comfortable with my work. And in 8.1.6 I need to get the size of G2. G2 is over there, and that's going to be quite nice and easy because it's inside of a triangle and we know the other 2 angles. So we can just do int angles of triangle. And just a quick recap of that theorem, all 3 angles inside of a triangle, interior inside, add up to 180 degrees. So this angle S plus U3 plus G2 will be 180 degrees, and that's going to form our statement and reason. This is our reason over here, interior angles of triangle. And we're going to write it up just like this, G2 plus U3 plus TSU. So this angle S doesn't have a name, so I'm going to say TSU. I'll go around the angle and then state the letters around it with S in the middle, then a copy on the S, equals 180. Okay, so we're going to swap these out. G2 is what we're looking for, so we leave him. U3 is 15 degrees as calculated in the previous question, so let's swap U3 to 15 degrees. And then TSU, this angle S is 75, so I'm going to switch this out to a 75. And then 15 plus 75 is 90. And if I move that 90 over, it becomes minus 90. And 180 minus 90 is 90 degrees. Triple check that with your calculator. Okay, let's have a look where our 3 marks will come from here. Our statement will get us our first mark. Our reason will get us our second mark, and the last mark comes from the correct answer of G2. And the last question tells us that the length of TS is root 80. Let's get that in on the sketch quickly. And now with reasons, we need to calculate the length of TG and leave our answer in simplest surd form. Alright, so we are going to be using a Euclidean theorem here. I've got a line from the center that is perpendicular to this chord TS over there. Okay, so running through that theorem, if I have a line from the center over here, and it's at a 90-degree angle, aka perpendicular to a chord, it's going to cut that chord into two equal parts, and a short way of saying that is the chord is bisected. So the length AB is the same as the length BC. So if we apply that here, we have our line from the center over there. It's at a 90-degree angle to my chord, so I know it's going to cut the chord exactly in half. So the length of TG is the same as the length of GS. And now to express that in my work, I say TG equals GS, and then this is my reason. Line from center perpendicular to chord. So it stands to reason that TG will be half the length of this root 80. So let's write that out quickly. So there's a couple of ways I can write that out. I can say half times root 80. I can also write it like this. Root 80 divided by 2. A half times something or dividing it by 2 accomplishes the same thing. So I prefer the previous one, the half times. It just makes more sense to my brain. And I'm just going to chuck that into my calculator, and my calculator will turn it into the simplest surd form for me. So we just pop that in, press equals, and I get 2 root 5. And if they don't give you a unit, it's recommended you literally write the word unit next to that. And that will officially wrap up question 8 from this paper. So let's quickly have a look where our 2 marks come from. So the first mark comes from your statement, and the second mark comes from your reason.